We do believe it's time for yet another adventure and to make humanity multiplanetary. So, with this adventurous topic, I, Shivani Singh, student of ABSIT Ghaziabad,
I, Shivam, student of ABSIT Ghaziabad.
Hi, Saurabh Pathak, student of ABSIT.
And I, Vedant Agarwal, student of ABSIT Ghaziabad.
are here to take you to the Mars and let you feel the happenings and vibes of the Mars. We, first year student of ABSIT Ghaziabad, would like to express our heartfelt thank of gratitude to our teacher, Ms. Anjali Dubey, as well as our director, Mr. Manish Kumar Jha, who gave us the golden opportunity to do this wonderful project on the topic Life on Mars, which also helped us in doing a lot of research, and we gained knowledge about various new things and saw various aspects of concerned topic. So guys, on the screen, you can see the following content related to the presentation.
So, the first question coming in your mind is, what are the challenges on Earth? What's the need to shift ourselves to somewhere else? The answer is very clear. There are various reasons and concerns to shift the humanity to other planets, some of which are listed below. First, survive asteroid impacts and such dangerous situations. Second, one of the major concerns is the population growth and our planet Earth will become overpopulated in. Third, vast resources are thought to be available on other planets and in space which are yet to discover. Fourth, to ensure survival of our species and to save the environment of our Mother Earth by moving people and industries out of here.
You want to wake up in the morning and think the future is going to be great. And that's what being a spacefaring civilization is all about. It's about believing in the future and thinking that the future will be better than the past. And I can't think of anything more exciting than going out there and being among the stars, said by Elon Musk.
Yeah, truly said Shivani. So I think till now we are clear with the question why we need to shift. Definitely curious people must be thinking of why Mars? The answer is at an average distance of 140 million miles. Mars is one of the Earth's closest habitable neighbors. Mars is about half again as far as from the sun as Earth is. So it still has a decent sunlight. Its atmosphere is primarily carbon dioxide with nitrogen and argon and a few other trace elements, which means that we can grow plants on Mars just by compressing the atmosphere. Moreover, the gravity on Mars is about 38% of that on Earth, so you would be able to lift heavy things and bound around. After all, this what remains is the fact that the natural duration of day on Mars is remarkably close to that of Earth. Now, let us focus on details about Mars. The age of Mars is 4.5 billion years. Its diameter is 6,791 kilometers. The day length is 24 hours and 37 minutes. The force of gravity is 38% of Earth. The average distance from Earth is 225 million kilometers. There are two moons and time to reach is 6 months. Let us focus on the inventions to reach Mars and to return back. SpaceX, owned by Elon Musk, created Starship spacecraft and heavy rocket which together create a reusable transportation system that is capable of an orbit refilling and leverages Mars carbon dioxide and water resources to refuel on the surface of Mars. Let's see happenings during landing on Mars. Spacecraft will enter Mars atmosphere at 7.5 km per second and will deaccelerate aerodynamically. Its heat shield is designed to withstand multiple entries, but there can be seen some wear and tear because of hot atmosphere.
Now I would like to invite Shivani Singh to tell us about the search of habitability.
Search of habitability. The confirmation of past existence of surface liquid water, the curiosity, perseverance, and opportunity rovers started searching for the evidence of past life, including a past biosphere based on autotrophic and chemotrophic microorganisms, as well as ancient water, including river plains that may have been inhabitable. The search of evidence for habitability, fossils, and organic compounds on Mars is now a primary objective of being space organizations like NASA and ESA. What will we need to live on Mars? So let's know the physical needs and the technological needs. The physical needs: water, air, food, sunshine, clothing, building. The technological needs: electricity and internet, materials, tools, computers and communication centers, vehicles and fuel, robots.
We are heading toward the challenges for livelihood on Mars. So these are: first, electricity; second, cold climate; third, biosphere for building. First, electricity. Electricity is proved to be one major concern for researchers and scientists for Mars mission. Nuclear power plants are problematic on Earth, so they can prove to be a worse Mars. To resolve a problem, we have to find energy source that can be sustain and generate energy for one such a big planet likewise uranium. Another aspect that is solar power can be taken in consideration, but amount of sunlight we could be get on Mars is even less than now get on Earth. But it is a lot of wind present. There are also air present is seen, so we can generate a good amount of wind energy. Cold climate. Recent models have seen that even a dense CO2 atmosphere, yearly mass was colder than Earth and ever been. Local warming of environment by volcanism and impact would have been sporadic, but there should have been many events of water flowing on Mars surface. The exact cause of are not well understood, but may be related to a combination of processes, including loss of early atmosphere or impact erosion, or maybe both. Building a biosphere. Beginning are some hardly radiation and cold resistant molecules and microbes. When take a aquatic plant to convert atmospheric gas to oxygen, water will also provide protection from UV rays. Rising oxygen level will result a formation of ozone layer providing UV protection. Eventually, human can walk around the Mars without a spacesuit.
Thank you, Saurabh, for telling us the basic challenges. And now we look upon the needs and how they can be produced on the red planet. Food. Mars dirt is not suitable for agriculture, so food has to be grown in sealed greenhouses. This, the background image, is a prototype of one of the sealed greenhouse made by the scientists of Earth. Practices like hydroponics and aquaponics will also be seen. Water. Majority of water is present in frozen form, which is harder than rock and so very hard to dig. So we have to heat up the ground, cause the ice to sublimate, and then capture the steam which can be condensed afterwards, providing us liquid water. Infrastructure on Mars. Because of the low gravity and thin air, which we will need lesser material in the construction of any type of buildings there. Low gravity, that is 38% of Earth, and thin air. Air is very thin on Mars and wind speed is very high. Because of these two factors, we will need lesser material in the construction of any type of building. The second biggest problem is the radiation level. As Saurabh told us, there are very hard radiation present on the red planet. Roofs should be made in such a manner that do not accumulate the piling of dirt and sand. One way is to build underground habitats to protect the people from radiation and also will be easier to keep warm, and other efficient and convenient way is to build dome-shaped roofs and buildings. Here you can see some of the prototypes accepted by our scientists of the infrastructure on the red planet. See, this is a dome-shaped building. This is the power generator and this can be used for a space center. Here you can see the underground food storage supply. Vehicles on Mars. Vehicles used for common transportation and services cannot be normal cars or bikes like we use on Earth. Special vehicles like pressurized rovers, ATVs or quad bikes like you see in movies and TV shows, gliders, planes, hot air balloons, and walking rovers should be made. Methane and oxygen will be considered as good fuel for these vehicles as they will be easy to make from Mars atmosphere as they are in plenty of amount. Now, after all this, concluding our presentation, I would like to discuss and gain information and viewing some aspects on our life that how the survival of planet Mars is acceptable, and are we ready to leave our planet Earth? Are we ready to colonize ourselves in space? Are we ready to build space colonies? So the answer can be obviously be vary from person to person as we have diversity of mindsets here. But seeing upon the existing and presently prevailing situations, all we can observe is that anything is possible. So for the mission to colonize a planet like Mars, we can all agree to a point that it is certainly possible. Difficulties and hazards may include radiation exposure, low gravity, isolation from Earth, like it is 225 million kilometers away from us, lack of water, and cold temperatures. But reason for colonizing Mars include curiosity, the potential for humans to provide more in-depth observational research than unmanned rovers, economic interest in its resources, and the possibility that the settlement of other planets could decrease the likelihood of human extinction. Yes, you heard it right. Human extinction. It could decrease the likelihood of human extinction. That is the biggest point. Now, after all this, thank you for participating us and hope you all like our work.